You know what's the irony is? What's meant to fix what's broken can often lead to breaking things. That's the irony with patching. You push a security update to close a vulnerability. Suddenly, your high availability cluster fails over incorrectly and production goes dark. The patch was supposed to protect it. Instead, it took you offline. And it's not just bad patches, it's the way most HA architectures handle routine maintenance. They are designed for failure recovery, not for planned updates. So every patch cycle becomes a gamble. Will the cluster coordinate correctly, or will nodes synchronization drift and trigger a cascading outage? Today we have with us once again Dave Bermingham, Senior Technical Evangelist at SIOS. And as we all know, he has spent years watching IT teams turn routine maintenance into production incidents. And today we are talking about the simple ways to make sure patching is safer and faster without redesigning your entire stack. Dave, it's great to have you back on the show.
Yeah, I'm glad to be here. Thanks for having me.
Dave, as much as we all love patching, they also make us nervous. Can you talk about why does patching remain one of the biggest threats to high availability, and where do most HA strategies break down during routine maintenance?
Well, patching is risky because you're intentionally changing something in a system that people rely to be stable. Most outages actually occur during maintenance and not during random failures. So when you apply a patch, you're introducing new code, new drivers, maybe a reboot. Sometimes these things interact with applications in ways that nobody expected. Where HA strategies often fall short is that they are designed with disasters in mind. So they answer questions of what happens if the server crashes, but they don't always answer the question, well, what happens when we purposely take down a node or an application to patch it? So if the architecture does not include a clear maintenance workflow, you end up with a lot of anxiety around patching. So people delay it, which creates security risk, or they rush through and hope nothing breaks. But a good HA design should make patching feel routine instead of stressful.
Can you talk about how can HA architectures be used to enable rolling or near zero downtime patching?
Right, yeah. The basic idea is pretty simple. Instead of shutting down the application to patch it, you move the workload somewhere else first. So in a clustered environment, you usually have an active node and a standby node. And the standby node is already running and ready to take over in those unexpected failures we talked about earlier. But in patching, you could patch the standby node first, and once it's patched and you know everything looks good, you fill the workload over to it. Now the newly patched server becomes the active system, and then you go back and patch the original node. And the same idea, if things didn't go as to plan when you patch that backup system, you have a simple way to roll back. You can just fail back to the unpatched node until you figure out what went wrong. But from the user's perspective, the application stays available or nearly available the entire time, with the interruption is just usually a few seconds during the switchover process. So instead of one risky maintenance event, you break the patch event into small controlled steps. So that approach takes a lot of the fear out of patching.
You work with a lot of IT teams, so you have seen the mistakes that they make. Walk us through the most common mistakes IT teams make when patching HA environments.
So one of the big mistakes is assuming that all HA solutions solve the patching problem the same way. But not all HA solutions are created equal. So for example, hypervisor level solutions like VMware HA or Hyper-V clustering, they're great for protecting against hardware failures or allowing maintenance on the physical host. But if you need to patch the operating system or the application running inside the VM, the workload still has to be taken offline, and so you have to schedule downtime for maintenance inside the virtual machine. That's where application level clustering becomes much more useful. So because the application is running on multiple nodes, you can patch one node at a time and perform rolling updates. The application keeps running while you update the environment, which will dramatically reduce the downtime required. But another common issue is configuration drift. So over time, servers start to look a little different from each other. Maybe one has a slightly different patch level or driver version or configuration setting. So everything works fine until the moment you fail over. Then suddenly the application behaves differently on the other node. So I see teams skipping the realistic testing. They may not test patches in a lab, but the lab environment does not look anything like production. So when the patch hits production, there are surprises. So the best practice is to rehearse failovers and patching procedures regularly so the team knows exactly what will happen when the time comes to actually apply that patch.
Now let's talk about what is the one simple step an IT team can take to make sure patching is safer, secure, and faster.
Yeah, you mentioned playbook, right? So one of the easiest things is to document and rehearse the patching procedure. So it sounds, pretty basic, but many organizations handle patching differently every time. So one person does it one way, another person does it differently, and that's where mistakes can happen. So if you define a repeatable process and a practice to make it easy during the maintenance window, the whole team becomes much more confident if you're all working off the same playbook. So even something as simple as running a planned switchover test before patching can make a huge difference. So if you know the application can move between nodes successfully, patching becomes much less stressful.
How do you see the future of patch management evolving?
Well, I think patching will become much less disruptive over time. We're already seeing that automation and infrastructure as code and more resilient infrastructures are already reducing the amount of time required for patching and minimizing that downtime. So instead of big maintenance events where everyone stays up late hoping nothing breaks, updates will happen in smaller increments and more frequently, with systems will be designed to absorb those changes while staying online. So high availability and automation will play a big role in making sure that happens. But the goal is to make patching almost invisible to end users. So security updates will still happen, systems will stay stable, and organizations do not have to choose between protecting their systems and keeping them available.
Dave, thank you for joining me and sharing these insights.
Sure.
Patching doesn't have to be a production incident waiting to happen. It's about designing HA architectures that actually support maintenance instead of fighting it. Thank you for these great insights. And as usual, I look forward to the next conversation. Thank you.
Yeah, look forward to next time. Thank you.
And for those watching, if you're facing similar challenges with patching and high availability, make sure to check out SIOS Technology and its solutions. And don't forget to subscribe to TFIR, like this video, and share it with your team. Thanks for watching.